In this problem, we are asked about an arrow that is projected vertically upward from ground level, and we're told its initial velocity. And the question is, how high does it rise? So a couple things to note. The initial position, or S naught, of the arrow is implied to be 0, ground level, and the initial velocity, or V naught, is 24.5 meters per second, which means this initial position is 0 meters. Now, you could have memorized the function that would always represent the position of a projectile. But if you don't have that memorized, there is a fact that you can know and then derive it. And the fact that you can know is that for a projectile, the acceleration at any time due to gravity is negative 9.8 meters per second. Or, if you're dealing with feet, it's 6 meters per second squared, or it's 16 feet per second squared. We'll focus on negative 9.8 because our units are meters. So at any time, this is the acceleration on the arrow, and its integral would give us the velocity on the arrow. So if I were to integrate this, I would have v of t, so v, the velocity at any time, is equal to negative 9.8 t plus some constant. And this constant I can solve for when I set t to 0, because when t is 0, then v of t is the initial velocity, and I already know the initial velocity, so that means that the constant in this case, when t is the constant, is always the initial velocity. So a velocity function must always be equal to negative 9.8 t plus the initial velocity. And if I were to integrate this, I would have the position function. Integrating this, I get negative 4.9 t squared plus v naught times t plus c. Notice that if I go to solve for this, solve for c, when t is 0, both of these portions drop out. So that means that S naught is the constant in this case. So a position function for any projectile motion will always be negative 4.9 t squared plus the initial velocity times t plus the initial position. Right? And we derived this just from knowing the fact that of what the acceleration due to gravity must be. Or you could just memorize this position function. It doesn't really matter. Personally, I can just derive it, and I've derived it enough where I have it memorized. So this is our position function, and the reason that will be important is we want to know how high does it rise. So first, our specific position function for this instance is negative 4.9 t squared. The velocity is given, it's 24.5, and the initial position is 0. So this is our position, and what we want to know is how high does it go. And I notice that this is a quadratic, so I want to know what is the y value of the vertex. Now, it's fairly common for people to know how to find the x value of the vertex, and by virtue of knowing the x value, they substitute it back in to the quadratic to solve for the y value. There is a formula for the y value of the vertex, and the y value of the vertex is always c minus b squared over 4a. So you can continue to use common practice, find the x value of the vertex, plug it back in, get the y value of the vertex, or you could use this formula, which always gives you the y value of the vertex, which is what we want in this case. You will find that y at the vertex is 30.625, which would be the maximum height of the arrow, and this would be in meters.